In this video, we're going to learn how we can use vector diagrams to find the resultant force of an object. There are two ways to achieve this, graphically and via calculation. To calculate a resultant force using the graphical method, we will need a scale. Let's set it at 1 Newton per centimetre. Here are our vectors, and I'll add a grid of 1 centimetre squares so it's more obvious. However, in the exam, you might not get a grid and could be expected to measure the vectors yourself with a ruler. Vector A is 6 centimeters and vector B is 8 centimeters. By following the tip to tail method, we will move the tip of vector A to the tail of vector B and draw a line across them. Because everything is to scale, all we have to do is measure the resultant force, which is 10 centimeters long. And by converting this measurement, we find that the resultant force of vector A and B is 10 newtons. Now for the calculation method. Questions that rely on this method will tend to require either trigonometry or Pythagoras calculations to be used. Here's an example question. A toy car is pulled by two forces, 10 newtons due east and 5 newtons due north. Calculate the magnitude of the resultant force and determine the direction of the resultant force, giving the angle north of east, brackets no decimal points. First, let's draw a compass. I use the mnemonic never eat shredded wheat to remember the directions. If our toy car is experiencing forces of 10 newtons east and 5 newtons west, the resultant force should be pointing somewhere northeast. And by assembling our force triangle, Pythagoras can be used to find the magnitude. Substituting our values into a rearranged a squared plus b squared equals c squared equation gives us a value of 11.2 newtons. And now all the sides of our triangle have been calculated, we can use trigonometry to find the angle of our force. SOHCAHTOA can be used to remember what function will be needed by labeling our triangle. Hypotenuse is the longest side, adjacent is the side next to both our right angle and angle we are trying to calculate, and opposite is our remaining side. I used the inverse tan function to calculate our angle. TOA has O over A, so opposite is divided by adjacent, giving us 0.5, which is then put into the inverse tan function, leaving us with a value of 26.6 degrees. This is then rounded up to the nearest whole number, 27 degrees. So our resultant force is 11.2 newtons at 27 degrees northeast. I hope this short refresher video helps. If you'd like a more in-depth video, feel free to subscribe and comment down below.